Hello, and welcome to MQTT and QUIC, a new standard for connected vehicles. I'm your host, Ernest Russell. I'll be leading our webinar today, along with my colleague, Josh Eastburn. So a little bit about myself is I have over 10 years in the broadcast industry, working for major media corporations, including CNN, Turner, and Fox. And so extensive background in IT. And now as a technical content manager for EMQ, my focus has been IoT, IOV, Internet of Vehicles, and also MQTT. So I'm very passionate about sharing my IT experience, and also I'm very much a car guy. So today's topic has me very excited. So a little bit about my colleague that's joining me, Josh Eastburn. Josh spent over a decade as a control systems integrator and automation engineer and project manager. Josh has worked for some major semiconductor organizations, including Intel and Samsung, and has some great IT experience, as well as experience in IoT, the Internet of Things, and IOV. So he'll be joining me to help share how both MQTT and QUIC can benefit connected cars or connected vehicles. So let's get into the agenda here. So what we'll cover today is first, I'll tell you a little bit about who we are, EMQ, and also some of the industry challenges around IoT and IOV, connected cars. I'll give you an introduction to MQTT, an introduction to QUIC, and then Josh will join me to help cover why QUIC and MQTT together are great for connected vehicles. We have our developer and one of our sales engineers that have joined us today. Thank you, Mohib and Mark. They will be available for our Q&A session at the end. So I ask, if you do have any questions, please use the Q&A panel to ask those questions, and we'll try to answer those questions live towards the end of the webinar. Any questions that we are not able to get to or unable to answer during this live session, we'll be sure to follow up with you in an email. All right, so let's get started here. So first, a little bit about EMQ and connected vehicles. We are very much involved in the IOV industry. We currently work with over 20 global vehicle manufacturers to help with their MQTT messaging as their MQTT broker. We also work with over 30 telecom providers to help keep those cars connected. So in total, we have over 20 million vehicles that access EMQX Enterprise and Cloud within our ecosystem. So we're very proud of that. And also another first is that EMQ and EMQX products are the first to implement MQTT over QUIC. So we'll tell you a little bit more about that and what the advantages are today. So Josh, could you join us and tell us a little bit about the industry challenges around IOV and connected cars?
Yeah, definitely. Thanks for the introduction. Too kind. So we always try to frame these discussions up in terms of industry challenges, right? Because that gives us the why, to this whole discussion. And as we've worked with some of the different, companies that you mentioned, Ernest, these are the areas that have stood out to us as the pain points that are driving growth for the connected vehicles industry in particular. So underlying problems of connectivity and stability, data collection, there's a drive to develop the technology, right? The internal capability to launch new services quickly, right? The future is the connected vehicle. And that means being able to, I guess, shift the development model in-house from how do we design services that run on the car to be more agile, more flexible, and more affordable. And so MQTT has a lot to do with that, which is what you're going to talk about. And of course, as vehicles become more connected, security becomes a bigger issue, right? There's personal information, that's at risk of exposure. Obviously, OEMs want to have control over how much data is available to outside parties, and there are a lot more parties who will be interested in having access to that data in the future, right? Regulatory boards, dealerships, maintenance, service techs, right? Lots of different groups will have an interest in having access to the systems that we are talking about building today. And then along with that, the greater demand for data by all of these different groups means that performance challenges will only be increasing. So stability, the ability to deliver a quality of service, right? That kind of guarantee is really what we're going to be talking about today.
Nice. And so with all that data, I would assume that there's also a concern for security, right?
Yeah, absolutely. Yeah, like I mentioned, multiple groups of people are going to be interested in having access to vehicle data for different purposes. So having not just security sort of end to end, but being able to do that within like a multi-tenant environment adds another layer of complexity to the security problems that we're thinking about.
Right, right. And I see from this graphic here, I can tell that there are many sensors. There are a lot of data that's being collected just within the car, right? And so we have all of that data, and we need some smarts in order to determine what we're sending to the cloud, how we're going to cipher through all of that data, right?
Yeah, absolutely. And part of what we have discussed in previous webinars, and I definitely recommend that attendees look back at our last webinar if you haven't for more of a dive into MQTT. We also cover some of the architecture about how those MQTT-based connected vehicle systems are brought together.
Thanks, Josh. So that's a great introduction for me to get into what is MQTT. And I see that we have different titles, different industries that have joined us today. And so I want to make sure that we all understand the key points here. So MQTT will help with those things that you talked about, Josh, with connectivity, with stability, with security, and it's a solution that can easily help with flexible data collection. So MQTT, it originally stood for message queuing, telemetry, transport, but now it's mostly just referred to as MQTT. And MQTT involves an MQTT broker, which in this diagram we see in the middle here, and that broker receives and routes messages from clients. And those clients could be a publisher or subscriber. And what that does, it gives us several advantages. And one is that all the clients do not have to communicate with each other, right? They can communicate with that central broker. And so it decouples the server from the application. So when we talk about especially scaling, we talked about the data, right? The amount of data that's required for solutions like connected cars, right? So this type of system is very good at collecting and parsing large amounts of data reliably and over different types of connections. And we'll talk more about that today. And Josh, again, will help us explain how that applies to connected vehicles. And so MQTT, it really shines in scenarios where there are two things. Either there's very little process or limited processing power on the device side, and also when there's limited bandwidth or network connectivity. And so in that case, in the case of connected cars, we see that. We also support a flavor of MQTT called MQTT-SN. And MQTT-SN is for sensor networks. And so these are for devices that are usually ran off battery. And so there are some improvements there to help with device power management. So typically MQTT we've seen run over TCP/IP, but recently, and again, EMQ is the first to implement this. Recently, we have been able to implement the MQTT protocol over QUIC. And so again, let me backtrack a little bit and let you know what QUIC is. So what is QUIC? So QUIC is a transport layer network protocol, and QUIC is built on top of UDP. It was originally designed by John Roskin while at Google, and it's actually used for more than half of the connections from Chrome to Google servers. And so it's very good with mobile networks. QUIC is today already, it's already supported by most browsers. So of course, Chrome, Firefox supports QUIC, Safari supports QUIC, even though it's not enabled by default. All of these browsers currently support QUIC. And so in most cases, there's nothing new that needs to be added to be able to implement the QUIC protocol. And so QUIC has it has become the underlying protocol also for our next generation HTTP3 or HTTP protocol. And so and actually most of the benefits brought to this new version of HTTP were brought through the delivery of QUIC. And I'll say specifically, QUIC has several advantages over QUIC and UDP have several advantages over TCP/IP. And one is that one of the most important in this case is that QUIC can switch networks pretty seamlessly. So whether that is a change in networks or a change in IP address, QUIC is able to easily handle that. And that's handled through a unique identifier between client and server. So what ends up happening is, let me forward to the next slide. This will be easier to understand here. And so what we've done is at EMQX is we've replaced the traditional TLS TCP layer with QUIC and UDP. And so again, the advantage that gives us is one, we're able to do better client migration because of that unique identifier. Also, we're able to communicate our encryption faster. So versus TCP and TLS, we usually have to establish in a communication, then we have to establish the encryption layer before we start to exchange data. And so with QUIC, we can actually do that in our initial communication, which means we end up with either a 0 round trip or a 1 round trip connection. And so, Josh, that brings us back to the conversation. Now that we know a little bit about what what is MQTT, and what is QUIC. Let's talk about more about how that applies to connected vehicles.
Yeah, good question. That is why we're here. So I think what has been interesting for me as I have done my own research on QUIC is kind of seeing the history of it, right? How did it come about, right? TCP has been the protocol underlying the internet for a generation. It's done a great job. But looking back at like some of the early tech talks from the Google developers talking about why they were working on QUIC, they're looking at a couple of issues with the evolution of the internet, right? The advent of mobile internet introduces a new set of problems, right? Not really faced, during 90s internet time. And with, we were talking about mostly static, connections, or if, hardline connections to workstations. Okay, so now we have connections that are moving around an environment. And on top of that, we've added, high bandwidth video streaming and stuff like that. So they're looking at how do we deliver a better internet experience for everybody, right? And TCP creates this issue where because it tends, lives so far down in the kernel, it's hard to make changes. Certainly, the Google team wasn't the first one to try and solve this problem. Other people have looked at making modifications to TCP, but it's so hard to push those changes out, right? 5 to 10 years before you really see any adoption of those kinds of changes. So they took this approach that allowed for a more flexible transport protocol. And along the way to solving the latency issues that they were focusing on, they also addressed some of these other issues. And the issues of mobile internet have a lot to do with connected vehicles, right? Or the internet of vehicles. All of those issues that you might deal with, like frequent network switching, going from Wi-Fi to cell, switching from cell tower to cell tower, those are all exacerbated in the connected vehicles use case. So MQTT over QUIC has a lot to do with connected vehicles, in large part because of what QUIC does for mobile internet. Okay, this is like the most mobile internet when we're talking about connected vehicles. And we'll dig into that a little bit more about some of the physics that are at play that create some of these problems, which probably a lot of our attendees are familiar with. But so the ability to switch smoothly from one network to another network, right, across an IP address change or something like that, that's very relevant for a vehicle that's moving through a physical environment, like I described earlier. Obviously, if we're concerned about the quality of service that we're providing to a vehicle operator, then QUIC has a lot to do with that. Also, simply because it offers better guarantees of performance, but then also because it can reduce the number of network dropouts. You're dealing with less data loss and less reconnection. So that's good for the driver. That's also good for the service operator, right? So on the operation and maintenance side, that means you're dealing with less variation in the way that the network is operating. And so even in very challenging circumstances, QUIC will deliver that a better experience than what you would see with a standard TCP connection. We'll compare those a little bit more in detail. And in fact, specifically, what we've done is prepared a little demonstration of what an MQTT or traditional MQTT over TCP connection looks like compared to an MQTT over QUIC connection. And specifically, this ability to handle network switching more smoothly. So we're going to hand off to Mohib to show everyone what that looks like.
Thank you, Josh. And just give me 1 second here to switch our share to get Mohib's demo going. Okay, and just a little background about this demo is that, for one, this can be ran by our customers. It is available in our GitHub. So this is a test that you can perform yourself here. So let's hear from Mohib.
For this demo, we've deployed several instances using CDK, one being an EMQX broker instance and several load generators. We'll use this to create two publishers, one using a standard TCP connection and one using a QUIC connection. Then we'll test a NAT rebinding scenario where we'll see how this affects the clients and how they publish messages. We'll also have two subscribers to show receiving those messages. Over here, we have our load generator instance. First, I create the standard TCP publisher. Then I create the QUIC publisher. Then I create the TCP subscription and the QUIC subscription. We see that both are receiving messages. We also see that we can monitor that these are all routing through this IP address. We can look here on the EMQX dashboard and see that messages are coming through. We have 4 connections and 2 subscriptions with the 2 publishers publishing. If we go to the second, if we go back here to our load generator, and we're going to rebind the IP address from 192.168.0.200 to 192.168.0.203. We see here where we're monitoring the IP address where all the traffic is being routed through, that it is now changed to .203. And if we return here, we'll see that the TCP connection disconnected, whereas the QUIC connection continued onwards. And that is reflected here as well. Now, if we rebind to the original IP address, which we now see happened here as well, we see that QUIC is still continuing to publish messages, and messages are continuing to be received through the subscriber. This demonstrates how powerful QUIC is in comparison to a standard TCP connection, which makes it ideal for applications such as automotive, where the connections can be unpredictable. And thank you, and with that, we'll pass it back to Ernest and Josh.
All right, so thanks, Mohib, for sharing that with us. And again, these are tests that you can perform in your own sandbox, or in your own proof of concept environment, and shows how effective those clients are. So now hand off to Josh to talk more about what we saw happen, and again, how that affects connected vehicles.
Oh, there we go. I know how to use Zoom.
Yes.
Yeah, so why is that relevant? We talked about how the problems of mobile internet are exacerbated for connected vehicles, right? So specifically what's going on? Well, you know, the laws of physics are pretty hard to fight against, and they really come into play here. So if you imagine a vehicle moving through a city environment, right? Maybe you start your car up and you're sitting in your driveway, and then maybe the car's still connected over Wi-Fi. And then you move from that, and as you leave your neighborhood, you're in this weird transition zone. This happens to me every day. You're in this weird transition zone between your Wi-Fi and the nearest cell tower, right? And in between, you get this, you know, weird spotty coverage where your vehicle's not sure which one it wants to use, right? And then as you move through the city environment, basically that continues to happen. You have no control over where these cell towers are placed. Hopefully they're placed strategically, you know, where you need them to be. But if you are a service provider for, you know, these vehicle operators, that's probably not something that you have control over. And so what that means is as these vehicles move through the environment, they're switching from tower to tower. And so what we just saw Mohib demonstrate of potentially picking up a new IP address over and over, that's what's going on within the vehicle's connectivity system. And that's something that you're going to need to deal with. And it's going to result in these temporary dropouts until the backend server is able to find the client again. And then if you think about maybe moving out of or into certain parts of the city, moving between buildings, losing line of sight, or leaving areas of maybe where there's dense coverage and, you know, moving to the fringes of the city or out into rural areas, then you've got other constraints on the signal quality of the available bandwidth, but that can happen within the city also. I was just talking with a researcher in the autonomous vehicle space a couple of months ago, and he was talking about doing some of their tests during rush hour traffic, right, on the 101 in the Bay Area. So even in an area that has a high amount of coverage, you have these fluctuations in the number of data consumers throughout the day. And you don't have any control over that. You might be able to predict it to some degree, but yeah, you don't have any control over how many people there are in a physical area trying to communicate on the network. So you need to deal with all of that congestion as well. So QUIC is relevant because it helps to deal with all of those different aspects of mobile communication. And I think just as importantly, the alternatives are costly, right? Again, you don't have control over where cell towers are placed, except for very few circumstances like maybe a railroad operator who can deploy a private network along an established route. But yeah, certainly within the city, you're going to be dependent on the carrier to improve their services. I know 5G is supposed to fix everything for everybody, right? But you probably don't want to wait for 5G coverage to be improved where your people are operating vehicles. MQTT over QUIC gives you a way to control the quality of service at the application level, right? So I think both of those things, you're dealing with a set of constraints that we really don't see in other industries, and MQTT over QUIC gives the service provider a way of determining how to deal with them. That's not dependent on them, waiting on other people or spending a lot of money.
Right. And money is always important, right, Josh? So when what I heard you say is that there are some other alternatives, but those alternatives are either one, very costly or very time consuming. Is that right?
Right. Yeah. Yeah. And getting back to, the industry challenges that we talked about at the beginning, speed to market is critical right now. That's going to be the competitive landscape, right? 5 to 10 years from now, when the expectation is that my vehicle is another part of my digital lifestyle, right? It integrates with my phone. It integrates with all of my services. Services are deployed to my vehicle as quickly as they are to my iPhone, right? That's the quality of service that OEMs are pursuing, and retooling and restructuring internally to be able to deliver on that. Well, these kinds of technology decisions, we believe, are what's going to underlie their ability to deliver on those services.
So when I hear you talk about quality of service, I think that would be a good introduction here to our next slide. And so how does MQTT and QUIC help us reach better quality of service?
So back to your introduction on QUIC, which is great. You pointed out that essential change of moving from TCP as our transport protocol to moving to UDP. Okay, why do that? So TCP is great because it guarantees this single ordered stream of data. But in the case that we're talking about, the Google developers were looking to create something that was more flexible. We can run into these issues where the data loss that we are going to experience in a mobile internet environment will actually makes the guaranteed ordering work against us, right? Because now TCP is going to hold up that whole stream of data, waiting for whatever lost packet didn't get through to be resent and to be received on the other end before it will permit all of that buffer data to be delivered as well. So we wanted to get around that problem. UDP doesn't include the guarantees of TCP. So instead, what they did, but again, to my earlier point also, making changes to TCP directly, that's prohibitive for other reasons. So by decoupling those two parts of the sort of the transport control algorithm, QUIC gives us a lot more flexibility. And essentially what it does is it's a multiplexed approach. So we can have multiple streams of data over a single connection. And those streams can be organized in a lot of different ways. And that's part of what we're building into EMQX right now, is support for different prioritization or flow control schemes so that when you experience data loss, there's a network switch or something like that, you can prioritize the data that you want to get through. Okay, maybe you're, for example, collecting a lot of telemetry data from a vehicle, and you can tolerate some data loss on that, right? Whereas maybe command and control messages that are coming from your backend system to the vehicle, you want to make sure that those go through when they get sent. So that's something that would be much harder to do with the TCP connection. That's not something that's part of MQTT in the way that we're talking about here. Although MQTT 5 does give you some limited control there. What we're talking about is at the transport layer, when QUIC detects, oh, the network's experiencing some congestion here, I'm seeing some data loss, I'm going to actually prioritize these streams of data and allow those to go through first, and these other streams will suffer the loss. But even in the case that happens, right, the impact is still not as severe. In the case of a TCP stream, you lose one packet in there, and we've got to buffer everything else that's coming through and wait for that packet to catch up again. In the case of QUIC, because we have multiple streams, if you lose a packet of data, only that impacted stream, or only that the relevant stream is impacted by that loss, right? So that stream within your connection will need to buffer until that data catches up, that packet catches up, but your entire data stream is not compromised, right? So that gives you a lot greater guarantee of the, again, quality of service, right? Or even in these challenging circumstances where you have lots of drivers on the road consuming your bandwidth, or you're having to deliver more data than you've ever had to do before, QUIC is just able to roll with those punches a lot more efficiently. And then on top of that, we're adding the fact that MQTT is designed specifically for that kind of unreliable network circumstances, right? Originally, that's what it was created to solve, for devices that are going to be in remote locations that may not have a consistent connection. And so it has all of the fault tolerance mechanisms built in as well to make sure that data can get through as your connection comes in and out. So that's two layers, where MQTT is at the application layer and QUIC is now addressing that kind of fault tolerance at the transport level. And then because QUIC is implemented the way that it is, right, not so far down the stack, but has some levers that can be adjusted at the application level, that means you can tune it for performance in some of the ways that I was talking about it. Prioritization or flow control of different types of data. That could be the quality of service class, right, of the MQTT data. That could be particular streams of data. That could be published data versus subscribed data, and using MQTT terminology there. But yeah, as a service designer, that really gives you a lot more flexibility to solve the specific problems that you're probably looking at when you think of connected vehicle service performance.
Nice. So I'm going to say, you said this, Josh, but I'm going to say this in a slightly different way, because I feel like this is one of our key points. And this is, again, what Mohib demonstrated in the technical demo, and one of the benefits that you described here. And in a more technical way, with TCP IP connections, each one of those streams that are connected would have to time out, right? When we have a NAT rebinding, we have a network change, or we have an IP address change. In TCP IP, each one of those will time out until we proactively establish a connection again. Versus with QUIC and over UDP, what ends up happening is when we have a disruption, only one of those streams are disrupted. And also we're able to reconnect without that timeout. And so the client, which in this case, the client being the application, it doesn't care, right? It never sees that the server went away. And we know from whether it's different mobile devices or devices don't typically react well to the network being snatched away, right? And so I I see that as a key innovation, especially as our infrastructure changes and we start introducing connected vehicles, smart mobility, smart infrastructure. This type of reliable infrastructure communication is going to be imperative to building our next smart cities and smart cars.
Yeah, that's actually a really good point. Just had a conversation with a telco provider not too long ago, talking about, looking 5 to 10 years ahead and trying to decide make some big decisions about building smart city infrastructure, right? And I was surprised to see how closely tied in with that some of these decisions are about the connected vehicle space, because that really underlies a lot of what will become part of the smart city infrastructure as well.
Mm-hmm.
And I wanted to take a second also just to clarify some of the different technical benefits that you outlined there. I think one is we're talking about MQTT over QUIC dealing better with data loss. And then sort of the next level down from that is in the case of a network switch, being able to handle that more smoothly without a loss of connection. And then also in the case that you do lose connection, being able to reconnect faster, like you said, 0 or 1 round trips, possibly. And then one thing that we haven't mentioned yet is the fact that QUIC encapsulates the TLS handshake also, right? So there's not an option if you're using MQTT over QUIC to have an unencrypted connection. All QUIC connections are encrypted. And that's part of how they've reduced the number of handshakes involved in establishing a QUIC connection, is because it encapsulates everything that you need in that initial handshake.
Good point, Josh. And it looks like we actually have some great questions starting to come into our Q&A chat here. And so what I will do is I'll give us a quick wrap up of what we talked about, and then we can get into some of these questions. How's that sound, Josh?
Yeah, let's do that.
Okay, so again, some of the challenges of connectivity, of reliable messaging, of spotty networks, changing networks, of limited bandwidth, of limited device computing power. The combination of MQTT and QUIC can be a way to deal with these issues. There are some other ways, but we said they're very costly and very time consuming. And so I'm excited to be part of the team that's introducing the first combination of these, and which brings me to my first question here is there a standard for MQTT over QUIC?
That's a good question. Yeah.
Yeah, so the answer for that is we are proposing a standard, working with OASIS technical committee, which we are a part of. And so we're working closely with them, and because we really feel like the combination of these two, both MQTT and QUIC, are going to be an essential part of IoT and Internet of Vehicles networks going forward.
Yeah, I'll add my piece to that as well. So QUIC itself has been standardized as, I think it's RFC 9000 by the IETF. RFC 9000 sounds like a EDM group, but
or a cool car.
I think that's what it is. I could be getting confused, but and then so that's already underlies HTTP 3. Okay, so the latest standard for HTTP. We are working on having a similar change added to the specification for MQTT, but MQTT was designed as a very lightweight specification so that it could evolve over time as transport and security protocols evolved along with the internet. So we expect that as QUIC becomes the standard for a lot of the internet, that it'll make a lot of sense for MQTT to standardize that as well.
Thank you, Josh. And again, some great questions coming in. One was, what does QUIC stand for? QUIC, again, was originally developed by Google. That version was called GQuic, and it referred to quick UDP internet connection. But it really does not stand for anything now. It's evolved. The current version is just referred to as QUIC, but initially it was QUIC UDP internet connection.
Similar to MQTT, right? Now it's just MQTT. Yeah.
Right.
I really like this question here from Han Lin. I thought UDP is not guaranteed delivery. Normally UDP is used for streaming video audio, but TCP IP guarantees delivery. So are we saying that UDP plus QUIC can now guarantee delivery? Yes, thank you for asking that question. So yeah, the difference is that we've moved those algorithms, right, out of the UDP layer and moved them up higher, or sorry, out of the TCP layer, right? The algorithms that it's using for error detection and order delivery, QUIC moves those up so it sits on top of UDP, where UDP does not provide those guarantees, QUIC does.
Right. So that, which allows us to put in some different smarts, right, and some different methods to ensure delivery. So it's, as Josh said, we don't depend on the operating system to do that work. Let's see here. One of our next questions is there any MQTT client library available that implements MQTT over QUIC? Do you feel comfortable with that one, Josh?
Yeah, there is, and we provide them. Yes. Yeah, let me think. I think there are other open source libraries out there for QUIC, and we have built MQTT functionality on top of those. We provide an SDK. We also provide a tool called NanoMQ that will directly bridge MQTT connections into MQTT over QUIC. I think I saw a connection about that as well. Like, how do we deal with that if we're already doing traditional MQTT? Can we turn that into MQTT over QUIC? So yeah, you have two parts to that equation, right? You need a server that supports MQTT over QUIC connections, and you're going to need a client that will create MQTT over QUIC connections. We can help solve both of those problems. And then specifically on the client side, yeah, whether you're looking to use an SDK to build that into an application that you're designing, or you're looking for a bridging solution, we have both of those available.
Thank you. And so again, thank you for all of those that have joined us live, but I've had the question several times on is the recorded video, or will the recorded video be available? Yes, it will. If you did attend live, you should get an email following the webinar with a link. And for those that did not attend, we'll make sure it's available on the website for them. Let's see here. So our next question is QUIC open source or is it proprietary?
Is that one for me too?
Yeah, well, actually,
it is open source. So yeah, we are first and foremost an open source company. Our open source, we started about 10 years ago with our open source EMQX broker. And typically when we're pushing out new technologies, they go into open source first and then into our commercial solutions. Our commercial solutions are often also open source, meaning paid, but in the availability to inspect the source code. And in the case of QUIC, yes, particularly because we're pursuing standardization of MQTT over QUIC, yeah, we expect to be sharing technology.
Thank you. And we also have Mohib here. And so if there are any questions that I put you on the spot for, Josh, please feel free to hand off. But you've been doing a great job so far in answering some of these questions. So let's see what the next one I can throw at us here. Okay, so the next question I have here is there a protocol stack of QUIC that you can share? And so I'll take a shot at that one. Again, we are, MQ is open source, right? So we try to the version of QUIC we use, the protocol of QUIC, is again, as Josh mentioned, open source. It is you can test in your environment now. We're very involved in GitHub, and we have several repositories that will not just help you get started as far as instructions, but our repositories will allow you in a few cases to spin up machines that will allow you to use our broker for testing, and including using the QUIC protocol. This is something that you can do today with our software. So this isn't something that's coming later. Today, you can start testing and hopefully implementing that now.
And Mark Fisher chimes in. Hey, Mark, thanks. That we are using MS QUIC, right? So that's the open source component underlying our MQTT QUIC solution on the QUIC.
Thank you for clarifying that, Mark. Okay, and so the next question I have from Han here is, thank you. Thank you for attending, Han. And do we know what protocols smartphones such as iPhone and Android use? And also the second part of that question is, how is MQTT and QUIC different? So I love that second question. So Josh, can you tackle the first part, and I'll tackle the second half of that question?
Sure. Yeah, so I would expect, particularly if you're using an Android phone, I would expect that QUIC libraries are probably already part of the OS, since it was developed by Google for Chrome. Yeah, in the case of iPhone, we, as Ernest mentioned earlier, we've seen some adoption of QUIC by Apple. So we know that it's available in Safari, although I think in the current iteration, it's not enabled by default. So it may be a similar case for iPhone, but I couldn't say specifically on that. Mark or Mohib, if you have any insight on that, please feel free to chip in.
Thanks, Josh. And there's Mohib.
Yeah, sorry, say that last part again.
Yeah, so the question about adoption of QUIC in different smartphone OSs, right? And my thought is, on the Android side, it's a guarantee. For iPhone, not so sure.
Yeah, I would imagine it's very possible. You can, of course, run JavaScript applications on both devices. So if there's a library for that, then there's no reason you couldn't use QUIC on an iPhone.
Yeah, that was my second thought also, right? Is like the part for QUIC existing is that it doesn't have to be implemented right at the kernel level. So you may not have to be dependent on your smartphone OS for an update to get that access.
Right. And that's a very, very good point, Josh, that I'll reiterate is that this infrastructure is already in place, right? In most cases, there's nothing new you need to buy, no new device, a new browser in order to implement this. UDP is a very proven technology that's been around for a while. And QUIC now actually has been around over 10 years. So it's and has been super reliable and stable over that time.
There's a question that's been sitting out here for a while, and I do want to at least acknowledge it, even though I think we should do an offline follow-up. The question from Anonymous is, could you then do millisecond response times on machine, I think in this case on vehicle, using CAN between OEM and third party? So this gets way back to the beginning of the presentation, where Ernest had kind of thrown up a quick architectural diagram of how MQTT might integrate with onboard systems and then move data off into cloud or backend systems. I will say, please follow up with me, josh.eastburn@emqx.io. And let's talk about that. We are considering doing a future webinar where we focus specifically on vehicle communication. As far as performance goes in general, though, I would say I'm probably not the expert to address that one. So let me bring in people who are and get that question answered for you.
Thanks, Josh. And so I will talk a little bit about the difference between MQTT and QUIC. So as I mentioned with MQTT, it's a messaging protocol that's designed to, again, for devices that have limited processing power and bandwidth. And so that messaging system, MQTT, can be used over different types of usually that's TCP/IP, right? Because for one, we want bi-directional communication, but we have seen MQTT delivered over other networks other than TCP/IP, whether those be proprietary networks or again using a different network layer protocol such as QUIC. So very, very different in that QUIC, again, being that network protocol that that sits on top of UDP, but separates the prioritization and the ability to retransfer packets. And again, MQTT is that messaging protocol that where the MQTT broker, that's us, we sit in the middle, and almost like a post office, right? You don't have to deliver to everyone you want to deliver to. You deliver to us, and we deliver those messages appropriately through rain, sleet, or snow.
I could think that gets to the question here from Lewis about, assuming I want this to stream car data to a database or server, is there functionality integrated into MQTT over QUIC? That's a great question that hits across MQTT in general, right? So backend integration isn't part of MQTT, right? MQTT provides lightweight publish subscribe messaging. What you do with those messages when you receive them, that is up to you. Or if you're using EMQX, we provide an integration layer that would allow you to move that data from the broker into a database or to a lot of other connected services. So if your database in your example has the ability to consume data as an MQTT subscriber, then your problem is solved. I'm not sure if there are databases that do that directly. So I think typically you have some kind of a bridging service in between. Our broker implements that directly. If you're using other kinds of IoT services, there will be some kind of bridging function. But if they support MQTT over QUIC, then that's how you would bridge that data into your database. Hopefully that gets at what you're hoping for. Yeah.
Yes, I think that answers the question, and we do have a couple of more here in chat. One, so this question refers back to the failover. So can I fail back from to TCP/IP from an active QUIC connection, and how long does that take? So as we mentioned, yes, you can switch, even though we are implementing QUIC over UDP. Most devices can make that transition and fall back to TCP/IP pretty quickly, but that is a responsibility of the device, right? And so in the case of browsers, as we mentioned with Chrome, for example, Chrome can, if that QUIC connection fails, QUIC over UDP, then we can fail over to TCP/IP within about 100 milliseconds. And so that's usually not perceivable to the human eye, and hopefully less disruptive to applications.
Mark Fisher, again, so Mark, someone who's been working on QUIC a lot, I know, or MQTT over QUIC, also chimes in. If you're looking for QUIC library specifically, he mentions Quiche, MVFST, MSQuick, and Lightspeed. Those are just the ones he knows off the top of his head. He's been involved in researching QUIC for a while. So thank you, Mark, for contributing that as well. And then I think there's a good question here that really gets to kind of what's the status of MQTT over QUIC. this is from MS, says, is this MQTT over QUIC ready to be implemented into SIMCOM modules? Where can I find information about implementing it into our sensors? So I think it's fair to say that where we are right now with QUIC is that it is in development, it's experimental. The reason for the ability to automatically fail over from QUIC to TCP is also important because we don't know if you might run into restrictions with UDP traffic, right? There are traditional reasons for blocking UDP. So that may be an issue as well that requires some research. So if you're interested in developing a proof of concept for your sensors, please reach out to us. And yeah, we would love to help you do that.
Yeah, that is a good point, Josh. And I want to follow up on that comment by saying I've heard that concern and seen that concern with many of our customers when you mention UDP, right? And they say, well, UDP is usually blocked by a lot of corporate firewalls, right? Yes, on certain ports, but usually there are other UDP services running, and it is accessible on certain ports. And so sometimes there may be some pre-configuration necessary, but in most cases we can pass that UDP traffic. Right. So it looks like we have answered all of the questions we have received in chat. And so, Han, thank you. We have a little bit of time, and Han has followed it with a question here. So components that are running MQTT over TCP/IP can also talk to MQTT UDP nodes, right? On a system level, software developers who only write code calling MQTT APIs, do they need to convert to MQTT over TCP/IP APIs? Do they need to change those or convert those APIs as long as we only call MQTT APIs? So did you understand that question, Mohib?
Kind of. So I'll try to rephrase this here. So you're trying to wonder if you need to,
if we need to modify our APIs to talk to both TCP/IP and QUIC.
Yeah.
If we're writing code for our components, how does that affect us?
Yeah, I think as long as it all depends on like the client library you're using, but I imagine they follow the same like publish and subscribe model and authentic.
Yeah, the vocabulary is going to be the same.
Yeah, so you won't have much change in your coding experience.
Yeah. Yeah.
Yes.
Just to make sure we've understood this correctly, like, yeah, if you have a broker that accepts MQTT over TCP connections, that broker will also need to support QUIC-based connections, and then likewise on the client side. But you could, at least with the MQX, our broker having TCP-based connections and QUIC connections coming into the same broker is not an issue.
Nice.
Get that right.
Okay, and so
the thumbs up from Hans, so I think we answered his question. Thanks,
yes, and thank you. We've had good participation today, good attendance. I would really like to thank everyone for joining us. Our website is full of resources. We produce blogs, technical articles, white papers pretty regularly. So I encourage you to visit our site, and thank you all for joining. And Han, thanks for the great questions.
Mohib, where can people find us out in the wild?
Yeah, if you go to emqx.io, you can check out our community page. We have a bunch of links on there to join our Discord community, our Slack, to find our forums and find us on all social media. And we're always happy to answer questions in those community chats. And we also appreciate if you share what you're working on, so we can.
Yeah, if you've got a quick project, we want to hear about it.
Absolutely.
Thank you. We are close to being out of time here. Louise has asked for the GitHub link that you used, Mohib, And so I will follow up with that. I will send you that link through email. Again, please go to our website. There's a plethora of resources as you do your research for new workflows or to implement tests. Thanks again for joining us, and we'll see you next time.
Bye, everybody.
Take care, everyone.